Yeah, I think we can start. So, good afternoon, everyone, and a very warm welcome to today's webinar. So, this is today's webinar will be focused on structural steel design using RISA 3D, aligned with the latest AISC 360 2022 revision. Myself, Ashwin, I'm Senior Sales Manager at Acero Consulting Engineers. We are the resellers of RISA 3D software along with all the RISA suite and channel partners of the mission. Today, we will show you how RISA 3D fits into practical design workflows and how teams are using it effectively in the real projects. Coming to today's agenda, here's a quick look at what we'll be covering today. So we'll start with a high-level overview of RISA 3D and where it fits into the steel design workflows. Then we'll touch upon how RISA 3D aligns with AISC 360 standards, followed by a live software walkthrough. We will also briefly cover integration with BIM tools, the licensing options it has, and support structure available. Finally, we will wrap up with Q&A. So feel free to note down all your questions as we go. You will also see a Q&A chat box on the top. Even during the session, if you have any questions, please do write in the Q&A chat box, and during the Q&A time, we'll try to address all your queries within the session itself. So here's what we hope you'll take away from today's session. The goal is very simple. You have a clear understanding of what RISA 3D can do and where it fits into your steel design workflow. We will also share some best practices so you feel confident applying it on real projects with reliable and compliant outcomes. Finally, we hope you'll walk away with very helpful resources. We'll also share documentation, learning material, and participation certificate to help you continue exploring the software on your own at your own pace. Before we begin, I'd like to introduce you to today's presenter, Mr. Kirti Chandra Joshi. He is structural engineer at Acero. Kirti holds MTech in structures from Delhi Technological University. He has hands-on experience on multiple softwares like RISA, Adapt, Bluebeam, Idea Statica, RFEM, and more. He'll be taking you through the detailed technical walkthrough in just a bit. So before we dive into the product, a few words about Acero Consulting Engineers. We are proud to have worked with more than 300 clients, delivered more than 30 products, and supported projects across 20 plus locations. Our team is made up of postgraduates from top structural engineering universities. We help our clients to enhance their productivity, streamline workforce flows, and get the most economical solution possible. And we do that through regular knowledge posters, webinars, resources, and we ensure that you keep learning and extracting more value from your tools, from your softwares. Coming to a quick overview of what we offer under our Nimishek portfolio, what all the softwares that we have currently. So we have RISA 3D that we'll be focusing on today. We have RISA Connection, that's for connection design. We have RISA Floor Foundation, that is also part of RISA suite. Bluebeam is a smart PDF collaboration tool. We have Adapt Builder and PTRC, that's for post-tension and reinforced concrete design. And we finally have Allplan. It's a BIM-based design platform for architects and engineers. Along with these, we also have softwares like Autodesk, Idea Statica, Karamba, Shuriken, and Aries Trinity. You can find details to all of these in our website. So along with these brief introduction, I would like to hand over to Kirti, who will take you through the software's core features and overview. So hand over to you, Kirti. Thank you.
Yeah. Hi, thank you, Ashwin. I hope my sound is audible, right?
Yeah, perfectly.
So yeah, hi, good afternoon, everyone. So for anyone like who is new to RISA 3D, I'll start with a short introduction. So RISA 3D is a powerful 3D analysis and the design software. It's from the Nemetschek group, which is used worldwide and in India as well. And I believe like most of you here are either working on the US project from India or supporting the US consultant through the outsourcing model. So the biggest question is like, can this software really handle the US design code? And like the answer is yes. So as you can see on the slide, like RISA 3D is not limited to just the steel. Like it can analyze the steel, either hot rolled or the cold from steel, and also the concrete, masonry, timber, or the aluminum structure. Basically, the structure of almost of any geometry or the complexity. So, but for today's, our focus is steel, like specifically for the AISC based steel design, and it handles the linear, non-linear, seismic, and the wind load analysis. And like I mentioned, it supports the multiple code. So these six are critical because like AISC 360, like design is never standalone. Like it is always linked with the ASC 7 load checks, like the stability check or even the secondary effects, so all of that. And RISA 3D is trusted by the large number of firms worldwide, and due to its flexibility and accuracy, it supports the various project types, such as you can see on the slide, like the residential or the commercial buildings. Maybe you are working on with the industrial structure or the stadium roofs or the PB kind of the structure, or maybe the pipe racks, the platform, the steel tower, the tanks. I mean, like almost the kinds of the structure like we say daily in the US outsourcing works. So the latest version of the RISA 3D is the version 23, which has been updated recently. So just to inform, like there have been several enhancement or the corrections made in this version as compared to the last version 22. Like for design, like it has added the member design as per the AISC 360 2022 revision, which is the 16th edition. Earlier in the version 22, it has the AISC 360 like the 15th edition. Along with that, it now have an like the ASC 722 for, and also the IBC 2024 load combinations. And also the new versions have added the response spectra generations, wind and the seismic load generation as per the ASC 7. So also, I would like to highlight that the enhancement, has been made in integrating with the RISA connection in terms of the load transfer, the member orientation, and more in this latest version, and also on the reporting and the print option. Like you can find the release note online and can have a look in more detail as well. So the next is the integration part of the RISA 3D. Like you can, integrate RISA with the tools like Autodesk Revit. Many of you are already maybe using it, or the Tekla, the STS2, ArchiCAD, and the Excel. Like this integration is achieved, basically through the links which comes within the RISA 3D. Like for example, like engineer can work, with the architect by transferring the models from Autodesk Revit using the RISA Revit integration. And also in the left right hand side, you can see RISA 3D can interact with the other RISA program like the RISA connection, the RISA flow, and the RISA foundation. So, typically the workflow is you can analyze and design the global steel frame in 3D. Then you can, push the member force directly into the RISA connections for detailed AISC connection check. Also, you can see the RISA sections, which allows you to create the custom shapes and the sections for you to use directly in the RISA 3D. So here you can see the types of the files RISA 3D support for both the import and export as a part of the file exchange. So regarding import, as you can see on the left hand side, it supports the RISA 2D file, which is the R2D format, and the DXF file, the STAD file, Autodesk Revit file, the Tekla structure, TNX tower, or the SAFE file. And in the right hand side, you can see it allows you to export your current RISA file as a DXF or in the Adapt Builder SAF, which is the structure analysis format file, and the STNF file, and also the model. You can exchange your model data to the Excel as well. So moving forward, like here are some of the key technical features, that showcase the RISA 3D use for our engineering work. Like the first is it allows obviously you to model this like almost any type of the steel structure, maybe it may be the simple buildings or the industrial frames, towers, or the complex geometry. You can use the advantage of the inbuilt templates from the RISA 3D, which saves a lot of time during the modeling. Like I mentioned, it supports both the hot rolled and the cold form steel, as well as the concrete, wood, aluminum, and the more. The next I have highlighted is for design. You can define the unbraced length directly to represent the actual bracing and the framing conditions. And regarding the effective length that we mostly get the queries, you can calculate it automatically, which is critical, when we are checking the buckling and the stability as per the AISC. Also, you can definitely work with the simultaneous model view. This is regarding the interface, and to make it more easier to review the geometry, loading, uh, and results efficiently, like you can animate your loads, the deflection plots, and even for the moving load, you can animate it with the speed control, just to to clearly visualize your load behavior for cranes or the industrial applications. And the next is, like once the analysis is complete, like it allows you to visualize and evaluate like your results with both the color coded graphics or the deflection animations or the contour plots. So yeah. So RISA 3D also here are some of other capabilities, like it allows for the analysis of both the 1D members, which may be either beams, columns, or the braces, or for the 2D elements like the plate and walls, and even for the 3D solid elements using the finite elements method. Like the next is it comes with the inbuilt AISC steel shape libraries, like so all the standard US sections, maybe the wide flange sections, the tube, pipe, angle sections, double angle, double channel, single angle, single channel sections, WT sections are already available. So for cold form steel, like the AISI and the manufacturer sections database are available, such as the SSMA, like the Marino Ware. ETC are included, which is for the light gauge steel structure. And like many of you might always might have used the RISA, so you might be familiar, like it supports the advanced effect like the P delta, the response spectra, and the time history analysis, which are often required for the seismic control project. Like you can also model like one-way members for tension only and one-way spring for modeling the soils and the other effects. And you can see like for the structures like the industrial structures like the pipe racks, the platforms, and the crane system, it supports the moving load, as I mentioned. Like you can run the multiple moving load case and directly see the governing effect within the model as well. The next feature I would like to highlight is the mesh generation. You can draw like a polygon with a number of sides to create a mesh of well formed of the quadrilateral elements. So these are a few of the capabilities that helps to move from modeling to understand the behavior and for your efficient design decision. Yeah. So, like as you can see here again, like it is related to some of the design capabilities. RISA 3D supports multiple steel design code, but like I mentioned, I focused here for the US code. Like it includes the latest 16th editions, like the AISC 360 2022 revisions, and it even have the older versions for both the AST and the LRFD. So like, whether you are doing a full 3D models or checking the specific members, like your designs stay compliant with the current AISC requirement, and even for the connection checks and the member capacities. Yeah. So next is like for the seismic design, it allows you to handle the seismic design as per the AISC 341 as well. Uh, it has also has the lateral load generations for the wind and the seismic as per the ASC 7 of the latest versions. It also include the accidental torsion, and for the seismic load case, it like the program automatically calculates the center of mass and the 5% of the accidental eccentricity for various of your seismic load case. And it also supports the cold form steel and the stainless steel design, like for the CFS member design. It also supports the CFS member and the CFS wall design, like the AISI 100 for the CFS member design, and for the wall it supports the AISI 240. And also for the stainless steel, it supports the AISI 360 2010 revision. And whether's like, next is like it also supports the wide flange design, like as per the, you might be familiar, ASC design guide 25, and you can generate the response spectrum graph as per the ASC 7. So the last is I have highlighted is the IBC 2024 compatibility, like with the latest version release of the RISA, like it is continuing to extend support for the IBC 2024. So as you might be familiar if you are working with the US project, like as of last year February, I think the UFC have officially adopted IBC 2024 for both the buildings and the structural code. That means most of the US government or the funded project now require the IBC 2024 compliance. So RISA makes it, updates it regularly and increasingly increase its important for the engineering firms working in the public sector as well. So as we know, like the AISC 360 specification provides the fundamental requirement, like for the design of the structural steel buildings in the United States. So like it covers the strength, the serviceability, the stability to ensure the safe and the durable structure. So we'll go through the modeling and analysis and member optimization workflows in today's webinar as we move forward. So we'll start with modelings of this tower structure and understand how the RISA advanced tools can help us in the modeling. There are opportunities to learn like how to use the RISA features and the grid templates with this model. And we'll get into some tools like the analysis offset, and then we'll build a large scaled model in the right hand side, you can see with the antennas, and see how to insert another RISA model into the existing RISA model through the Append features. So we'll take a look at the model video in the next slide. Yeah. So this is the interface of the RISA, and I've already opened my RISA license. And as you can see, you have the options. Once you have the interface, you have the options to create your new model and open your existing ones. And you have the options of your samples model that are already inbuilt within the RISA. So you can just open and verify some of your models as well. And in the below portions, you can see the recently opened project, and in like in the explore more options, you can see the tips and tricks. You can see the new features whenever there is new releases is coming. You can definitely just go through these options as well. So once you click on that, you will get to know about which of the latest version of the RISA is there. You can just click on that and you will have all the information regarding the enhancement and the correction in the latest version. So regarding there are several tutorials and the training module as well. So we'll start with creating one of our projects model that we have seen here for the latest tower. So I will just start it with filling the project information, the company name, and all the other information. You can just fill your model name as well. So I can just give it a name of the lattice tower. And this is the main workflow of the RISA 3D. Like you can see in the home tab, there are all the members, plates. This is useful for the modelings and to apply all the loads. And in the right hand side, you can see the Explorer where you can define your, you can start with the project grid as well, but you can start with this drawing, grids. Instead of the project grid, you can just use with the drawing like this, which I've already opened. We can do from this as well. And in the section set, you can just define your sections in the left hand side Explorer tab. You can define your sections. You have the options like you can define first a members and later you can define your sections as well, or you can firstly define your section sets. And this will basically help in your suggested design, like in the member optimizations. So we are going to build this model, and we'll see how we can quickly able to build this model using the inbuilt templates. So we are about to give the name for the column, and we are about to give the section set for the beams and the braces as well. So for the column, I have used the SSS section, tube section. So you can see the AISC database has been there along with all the other database. You can I've used the AISC database. You can see the property of the sections by click on the edit options, and I can assign type it to the column. And for that, I have assigned the materials of A500. It is for the ASTM like the grade B, which is mostly used for the tube sections. And similarly for the beams, we can assign our section sets and can assign, so with member type we can just change it to the column to beam. You can just whatever the angle size you just want to mention, you can just type it. I've just write L3/3, so it gets given me the shape, and you can just view and edit its property as well. Otherwise, you can just search it from the database options as well. So it is for the beam, and it has automatically, change its design list as well. So we have assigned the A36 grade, which is like the mildly structural steel grade, mostly for the angle in the channel sections. And for the braces, we have again assigned the sections of 3/3 into 6. Then after we can just assign it as a type later, and then it will change its design list as well. So I prefer this way, like first created the section sets so that it will help me in the member optimization design at last later, so that I will have the particular only the section set for all of my members instead of generating all the members. For example, if you have 100 members, if you do not define the section set, it will just generate member 1 to 100. So if you have put that sections into that member section set, it will just give you one of the section set for that 100 member. So for the braces also, I have assigned it as a material of A36. So as we can see in the model, we have the columns, beams, and we have the horizontal brace and the vertical brace. Top brace, like we have assigned it as the horizontal brace. So I've just created my section set. Then I will just use the grid template feature to create that lattice tower types of the structure. So in the template, you can see the 3D grid options. Right now, I am not interested in generating the plate. So I'm interested in only the members. So you can just untick the plate options within the 3D grid, and you have the options to fill all your properties for your X member. As you can see, X, Y, and Z members. For the material is the hot rolled steel, and for the section set in the horizontal, X and Z is my beams, and Y is verticals in RISA by default. So I will treat Y as the column and other as the beam. So the number of increment I have seen earlier is 1 in the X and 1 in the Z directions. So it is Like you can see, there is one and one in X and Z. So I will just use a panel length of 4 meter in both the X and Z directions. Similarly, for the Z members, my increment is 1 and the panel length of 4 feet. And in the vertical direction, you can see the 5 increments of panel feet of each of 5 feet. So I can just fill this data template to generate the geometry. So for my vertical member, I've just for my y-axis member, I've just changed it to the section set as column from beam. So once you click on OK, it is ready to view your models. Now you can just hide your grid options, and your model is ready using the like the grid template. You can assign it in the wireframe view to see like the section set which we have created for the columns and beams. It is displayed in the different color. And even in the rendered view, like you can see all of your sections. Right now you cannot see, you are not able to see the full transparency, because that will see how we can adjust to see the full member length here. That we'll see in this video as well. For example, if I want to assign a section set to my B member, I can just, right now you can see my angle sections. I just want to rotate it by a few degrees. So what I can do is I can just select a line, and I can just select it and rotate it at a once. Because the orientation is something different. Right now you can see the orientation looks good. So you can just use that line feature to select all of the elements. And so you can also display the local axis just to evaluate, just to check it for your reference. So we'll assign a different section set as well. Like you can see, once you click on the property options in the left hand side, you are able to assign the section set. For example, we are going to create our brace members. So we have already created the section set for the brace. So right now we are just using the property of the section set to create the brace element. And once we have created it in one part, we can just use the copy feature just to copy it in the above. You can easily rotate your models by clicking the mobile pan and the shift. So, sorry, the mouse pan and the shift. So I've used the copy features by giving the number of increment of 4, so that you can just select and just copy it. Right now you can see in the section said my braces has been shown. Now we'll create a brace at the top as well. You can just rotate it like the way which in which view you want to see. Like for the top brace, we can just use the section set. Even if you want to select any of your in the model, like any of your members, you can just use the select by property options that is under the home tab. And for example, you have the different options to select your particular members, as you can see on the screen. Like for example, I'm interested in by the member types. For example, for the columns, then if I click on select and override the previous selections, means here, like if you have already selected any of your beams member, for example, earlier, then if you select the override, it will just delete that previous selection and only select a column member right now. So right now, just for my reference, I have used this, and if I click on select, it will select all of my column members. And if I click on invert selections options, and it will just select all of my members except my column. For example, I have selected these braces, so I want to assign the releases so that only axial force is transferred through these braces. I can just click on, I have already selected this, and in the left hand side to the property, you can see the I and the J releases option so that I can set it as pinned. You have the options to custom release as well. So for now, I have set it as a pin. So now we'll set up a boundary condition. For that, we have selected our below portions and in a one click, and we'll under the home tab, there is the options of the boundary conditions. So there is the options of different boundary conditions. For example, if I want to transfer my moment at the base, so I have used the fixed boundary condition here. So next is the basic load case, like you can set up your load case under the home tab. There is the load case option. So you can just give it a name for example, for the dead and even for the live or the wind load, you can just give a name and assign its category. For example, for the dead, I have assigned the DL, and for the wind, I have assigned the wind load case. The next step is before running any of the analysis, I just prefer to check all of my models. So under the modify tab, you have the options of model merge so that it will give me warning if there are any issues in my model. So if I click on apply all, right now you can see there is no any warning so that I can move forward with my model. So these are the basic steps I just prefer to run before jumping directly from one part to the another. So these are the load combination tab. You can just create your own combinations, or you can just generate your own custom, like you can generate the code based combination or can generate your own custom combination as well. So even for the like the LC generator, you can see for the gravity load, you can select your regions and the load combination code as well. Like right now you can see we have selected the US, and for the you can see the AISC and the IBC codes are already there, the latest revisions. So you can use this feature to generate your load combination for your project. So I just want to run, create my, instead of generating the load combination, I just want to create one self-test model just to check that is my model is behaving correctly or not. So I will just run it for my self-weight, so that since the vertical is the y direction, so I've just used a factor of negative y, -1 downwards for my weight load case test. Then I will just solve my current model. Right now the P delta has been off, so that we have given it has given me some warning. I will also display like how you can enable and disable a P delta effects. So right now you can see in my vertical x and z directions, the sum of the total reactions is 0, and it's only transferred in the y direction. So it seems like there is it's pretty good. Because we have run it only for the self-weight case. Now we can see my deflection plots. Like you can see, you can just create, you can just select the load category and the load combinations. So it hasn't given me much of the deflections. Right now we can just see it by giving scale factor of more value so that we can clearly see it, and we can also animate our deflections as well through the result view setting. Once you click on right click, you will see the result view settings, and under the deflections, if you want to increase your scale factor like the input value, you can just use that so that it will give you more, so that it will just scale up your values. And in the view tab, there is the options of the results. And in the results tab, you can just animate your deflections as well. Once you click on animate, it will animate your deflection. Also, you can set up your scales here. Like if you want to increase your scale, it will just increase your animations. So you can click for the undeflected shadow as well. Like it will just bring that shadow in the backward. So we can apply our load case. For example, I'm right now creating some point load at the top in the live dead load case. We can apply the wind load as a point load here. I will just apply it here. You can just check your directions because in that way we can assign your like the load case particularly. The basic step is to show like how you can create get this feature out in the RISA 3D. So you can see in the load case options, all of my load case has been assigned. So for the self weight case, like I can just drag it down within one view, like the model is in my below window and my load combination tab is already active in that window so that I can view it simultaneously. You can just generate your own like the load combinations for your deflections, wind and the seismic as well. Once you click on generate, it will just give you the load combination. The first three is for the deflections, since we have already marked the tick for the deflections. But right now I'm just checking it for the dead load and the dead load plus wind load, so that I'm just creating it manually. So I can just give a factor of 1 for both the dead load and the wind load. For the BLC, so I use DL plus WL so that I can get the wind load. And there is the options you can see solve current combination batch plus envelope. You can, if you solve batch plus envelope, it will give you the governing result for that all of your combinations. And in the below tab, you can see your loading for like the dead load and the wind load. If you click on the load combination, it will display both of the combinations. So you can swap between the load category and the combinations. Like you can easily view in one of the window by just dragging it one over the another. So now it has calculated me the nodal reactions, and it has also we can also check the P delta. Like the code check right now, our P delta has been off, so it has given not calculated our P delta analysis. We can change the setting. Like if you are getting this error, you can just check your settings from the RISA, like the application setting, whether this has been whether the code requires the P delta or not. So we can just check it through the file tab. Like right now you can see the P delta analysis is required because we have already opened this. Yeah, so in the file you can see the application setting, and within the application setting in the output, like once you click on the output, you can see the info code required P delta. Not calculated me the code set because we have not opened P delta analysis in our load combinations. So once you untick that, you will now get a solutions. Once you click on that, now it has calculated my code check. We have already created like our video, like our webinars in our last webinar regarding the P delta analysis. You can just watch our previous webinars as well. So right now you can see all of my code checks has been performed. So just to evaluate, once you click on any of your members, and if you click on show this in our model, like you will be able to see that members in our model in just one window. We can display the code set values in our models graphically for our particular combinations. You can see the code set values for this particular members is 0.39. So if you click on selected this, it will highlight in the graph by the blue symbol, and it is 0.39. So once you click on detailed report and that particular member, it will generate a detailed report for that members, including your code checks, which of the code which you have used. So it has given me the AST code check. You can change it through the code settings. I will just change it to LRFD as well, and we'll quickly see. And you will get all the limit state code check in your report as well for the axial bending and the for the bending and the shear interaction. So you will get all the detailed reports. So in the model settings, in the codes tab, you can see the hot roll steel, the materials in the left hand side, and the codes in the middle. So you can select the required code as per this. So right now the latest is the AISC 360, like the 360 16th edition. We have it's already here. It does have it does have the Indian code as well, but now we have just use the AISC 360 here. So once you set it from AST to LRFD, and in the report, it will change this from AST to LRFD check. Right now, you can see the AST LRFD code check values. You will get all the diagrams within your details report, and you can just print out your report at a later as well. So the next is the analysis offset. Will take one particular sections and will apply some offsets and check how it interprets its analysis result. And in the next part, we'll append, we'll insert one other RISA model into this one model, and we'll do some other modeling process. If you click on any of the members, right now it has shown me that it has been modeled center to center, like it will follow the center line analysis. But in the real case, we know that it will not pass directly in the center. So we can use the analysis offset feature here. You can just display your local axis in which of the direction you want to assign the offsets. And in the wireframe view, it has not shown me, but if I go on the render view, it will just show the offset properly. Right now, once you click on that and provide some offsets here, once you click on any of the member, basically in the left hand side in the property, you will see the options of additional property where you can assign this analysis offset and the resident offset as well. So we can provide offset of 2 inch. Now you can see it has been offsetted, but it will also generate some eccentricity here. So this is the way you can where basically we got most of the query, like how to create how to give the offsets here. So from the once you click on any of the member and so the additional property, you can able to give the offsets, but in most of the case the center line analysis is sufficient. We will also use how to create the rigid int offset. Basically, they are created within the ints of the member. For example, if you want to display your members, you can just display it which end is your I end and which end is your J end. So the red denotes the starting, which is the I end, and the green is my J end. And once you click on that particular members, and the property tab will open at the left hand side. And in the additional property, you can see the options of I offset and the J offset. Right now, you can see it has been model center to center. Now I will give offset. For example, this is my HSS 4x4, so I can give offset of 2 inch, like from both of the my member inch. So I can just write offset of I here as a 2 inch, so that right now you can see it has shifted my member inch from that center of the HSS. So while if you want to create offset in the J end, like you can see the members, like the column members is continuous here. So you can, this is the M26, you can just write M26 and it will consider its um, like the half depth, and it will offset it accordingly. Like you can just write here M26 and it will just offset my other ends. Basically, like if you have multiples members within one continuous member, it's basically to select all of that members and use the other members as a reference, so that you don't need to individually provide your offsets value here. So right now we'll also see, we'll also analyze this, and we'll see like how it will affect in our results. Like you can see the result links has been provided, and because we have already shifted by the 2 inch from both the sides. And to make sure that once you click on the model view setting, the rigid link will only appear if you have click on the rigid offsets as a tick mark here. So also the pin symbols we have already ticked, so we are getting all the values in our graphics view. Like we can see the rigid links here as well. Sorry. Yeah. Yeah, we can see the rigid links here. So we'll solve this, and we will check like for like where we have provided the offset, how it has changed my values. So if I'm interested to generate the share results, so I can click from the home tab. The results tab has already been active once the analysis has been done. And right now we can see the share value of 00 here. Like if you want to select that particular member, you can just use this dim lock features at the left hand side within the workspace. You can see the camera, like the eye icon here. It is the dim lock feature, like it is the view mode. You can just select the members in the result which you want to see, and it will just transparent the other members. So right now you can see the values at 00, but maybe if we increase the decimal values by a bit more, then we might get the exact value. This can be checked by from the in the view setting. You can see the results options, and in the result option you can see the force diagram, and here the magnitude decimal value is 1. So we can just increase its values to a bit more, maybe by 2, 3, or 4. I will increase. So now you can see the exact values here. For that, where we have added the releases, it's like obvious that we have reduced the share force here. 0.0098 and 0.009 we can see here. And if we want to check the report for both of this, we can just display both of the results in one, and we can just compare the results. And in the diagram here, in the right hand side, you can see the digit and has been applied, and it has given me the diagrams and the values accordingly. It's good to interpret it like in the results as well, like side by side comparisons between where you have provided the offset and not. For examples, in the shear force diagram, Y shear force, you can see it's actually taking the full length of 4 feet, and in the Y shear force in the left hand side where we have provided the offset, it has taken the length of the 3.67 feet because we have provided the offset from both of the end. And if you want to display its result, you can just click on that particular diagram, and it will just zoom in for that particular values. So you can see all of your limit state code checks as well from the reports. So I've selected it to none. And now we will just scale that model and place some antenna in that model. So basically, we'll use the append feature. We will just insert one RISA. We'll insert another RISA model into this existing RISA model. So in the modify tab under the scale, right now I have modeled the X and Y member as the 4 feet. If I want to increase it to the 6 by 6 feet, so that I can multiply it by scale factor of 1.5. So I can just write a scale factor of 1.5 into the X and the Z directions. And you can select any of the difference so that it has been scaled. Right now, my verticals Y has not been scaled, but X and Z has been scaled to 6 feet right now. So if I want to, increase the size of this tower, you can just use the copy feature and just uh, insert whole of the model just above it. So I have used the point-to-point copy features, and I have selected the bottom point and the top point so that it is copied above the structure that I have selected. Right now, you can see the boundary condition need to be at the base, but right now it has copied my boundary condition as well. Right now, it has shown me the 8 boundary condition instead of 4. We can just delete it. You can select the whole models, and in the boundary condition tab, you can just assign it to free. And again, in the boundary condition in the Explorer tab, you can see the boundary conditions. So right now, only the 4 boundary condition at the base has been assigned. Again, I have used the model merge feature just to check it down, and I see the model is good to go ahead. Now I will just save this model and use the another RISA model. I will just insert another RISA model into this RISA model. So I've saved it as a name of lattice tower. I can give it a name otherwise. Just I am giving the date of today's date, like 2026 02 6 February. So in the file tab, you can see the append features. So basically this append features, many of you might be already using it, but to anyone who is new, this insert the another RISA 3D model to this current model. For example, if you have any other model, so I'll just bring the antenna from another model to this model and just insert it. I will use the append features, and I have one model already created. So I will just use that, and it has inserted me. Then I will just play with it just to fix it where I want to fix it. Now I can save it in, there is something called saved selection if you are already working with this feature. So I will just show you the saved selection state that I will save this current view first and will just save it as a current. For example, if you are uh, to select this antenna which I have exported from other RISA model, it has just saved it my saved view. So in the next step, like if you want to select uh, or if you want to copy it, for example, like you may have to select each of the members, but if I have already it in my saved selection instead, it will automatically retrieve that whole antenna from that particular space, and I don't need to select it one by one for all of my members. For example, if I retrieve it, it will just retrieve as a whole, not just a part one by one. So right now the top is around the 25 by 25, 50 feet. So if I want to copy it around the 45 feet, I can just again use the retrieve from the saved selection instead. I can just select it and just copy it at 45 feet so that I can just use the point-to-point copy features, or I can just use the global move features. By copy feature, it will just create a duplicate. So I've just used the move feature here. So in the Yaxed view, I can just rotate it somewhere for a better orientation, maybe by 135 or something degree. So I created 45 degree. So once you click on apply selected in this node, it has rotated 45. Again, I rotated it by 45 and again 45. Now it looks good to me. Then you can just zoom in out and see that the nodes, right now you can see the nodes, this nodes has not been properly aligned with this, so that I can just create a dummy node here and we'll just ship that node to this intersecting node. I'll just create a dummy node from the home tab. So this retrieve feature is obviously helping me here, because I've already saved it in my saved selection instead. So whenever I want to select a whole of my this, so I'm just retrieving it from the saved selection instead. So I've already created a dominant, and using the point-to-point feature, I'm just copying it. So it looks now fine to me. We can just rotate our model. We can create some rigid link between this so that we can just provide the offset to this as well. Just I am retrieving it just to select all of my models and giving the offset of 1 feet. I can just we can set up the rigid links here as well. By this way, you can just use some of the tools within the RISA 3D just to speed up the modeling process. And you can see it in the section set. Right now, you can see the different section set for the column braces. The rigid links have been denoted by the green, and like the sky blue and the dark blue, we don't have it in the section set. So it has given me the YANA. You can also see the property by clicking on any of the members, and in the left hand side you can see it as the rigid. Once you click the material type to general, you will have the options of the rigid. And in the render view, you can see my whole of the model. We'll also fix like how to display whole of its full length member here. Once you click on, this is something related to the model view. For example, we have the rigid link here. We have the channel sections. We have the pipe sections. So I've already modeled it and used it here just to show the append feature. Once you click on right click, you will see the model view settings, and under the member, now you can see the rendered members of a lens is just set to 80% earlier. Now I have set it to 100%. Now you can see the full length of the member. Here you can see the full length of my member right now. So you can just click on your render view and your different members. For example, the earlier model which we have created is displayed from member, for example, member M1 to something like you are seeing member 148, M50. But the models which we have created, like which we have inserted from the another RISA model, are given with the name start from the member M1 underscore the one. So it follows this procedure so that we can just highlight, just get to know more about the members. And it has given me all the section shapes, design list set for that particular member. You can then just carry it out the procedure to take forward. So you can just once you click on any of the members, in the left hand side you have the options of releases as well. Right now I've set it as a pin already, and in this additional property below you can see the RISA connection property. If you want to particularly carry out the connection design for that steel structure, you can set out a rule and export the model to the RISA connection later. So this is integrated like the RISA 3D can be like you can do the superstructure analysis in the 3D and can set up a rule here and can perform the connection design in the RISA connections. Like even for the unbraced length and the effective length factor, once you click on any of the member, and in the left hand side design parameter, you can see the LB, Y, L compression. So these are the effective length factors for the column type buckling and the beam type buckling. You can just set out its value, and KYY is the effective length factor. You can just use to calculate your effective length factor based on the intelligence and the support conditions. So this is regarding the modeling, and in the next step, we'll see the workflow for the hot roll steel design. Like we'll discuss about the workflow for designing the hot roll steel structure in the RISA 3D. So the process of that helps us with the optimization as well. Like we'll create the section set at the step one and assigning the design list to each of our section set, and we'll also set the design rule for the members and perform the code checks on our structure. And finally we'll look at the suggested design to complete the structural to complete the structure entire structure design of our structure. We'll take a look at the model video in the next slide. So I've already my model here. So I've already model created. So I will just explain the workflow how you can carry it out. So I can just give it a model name. You can just display all of your information, model, company, and the designer name respectively. And in the home tab in the settings, you can have the options to work with your units like the imperial or the metric unit. You can just switch between any of the units at the any point of your time. So right now it's imperial. In the model setting options, you can set out your code as well. For right now, we'll set it to AISC 360, the 16th edition, the latest edition, 36022 LRFT. Similarly, for the connections and other, you can, for the code from steels and other, you can just select the all of your codes that is displayed from the model settings. So I have my beams here, like it's a frame, like I have my beams, braces, the channel section, like the angle sections, the girders, uh, columns. So I've already modeled this, and with a pin support, I can just display it with the color coded so that I can display uh, it more clearly. Right now you can see the diaphragm has been assigned at the top. You can see the material as well. Once you click on the material options, A992 has been assigned for all of my sections right now. It's basically the white flame sections right now I have taken. So I've assigned it as the A992. So all of the sections are as for the ASTM standard. You can get it in the RISA 3D, or you can just change its properties as well. So yeah. Yeah, we have already seen this, I think. So we have already displayed the materials. You can just display it once, like this is the symbols where you will have all the information regarding your members. And in the section material tab, you can see all of the materials are listed here for the hot roll. Similarly, once you click on the cold form, you will get all the materials based on that. So you can assign the materials accordingly. What we'll do here is we'll create a section. We'll just analyze the structure and we'll later assign the section set and design rule and design set, and we'll optimize the design for this. So I've already created my dead load and the live load as the distributed load. We have applied the area load, and it has already been distributed to the members as well. So here is just to evaluate how you can basically perform the workflow. And I will also show some of the features. So right now you can log into your unit setting as well. I've already generated some of the load combinations as well. If you can generate by clicking on the LC generators at the top, and as for the US 2024 IBC strength or the AC strength, you can generate as per their load combinations, and it is also the Indian standard as well. We have the P delta turned on right now here. To the director option, you will just get to know, like, if you have any of the queries regarding your topic, you can just select the director options or just F1 from your keyboard. It will just take you to the RISA help file, and you will have all the information. For example, regarding that P delta, you will have all the information related here. So this is just to see how you can just switch between the model file and the help file. By pressing the F1, you can just switch it, and you can just run the sol bash plus envelope just to run whole of your combinations. And we'll just see the code sec values, and later we will perform how to optimize our design. So once you click on the unity sec, it will give me some of the values here. Right now in the red, it is showing me my members are failing. We'll try to fix this. And in the particular load combination, we are seeing the particular code sec values. All of my right now my beams columns, all of my members are failing. So there is the options of code sec through the spreadsheet form. You can just sort it from the maximum to the minimum value. Once you click on any of the member, you can sort it from maximum to minimum. Right now we can see the maximum values of 3 point something. We'll use the program suggested feature how to optimize this design, like in the so you will also have the option. So once you have completed the design, you have your result tab active at the left hand side, and under that you will see all of your material takeoff information as well as the code sec values. So right now I have displayed the material takeoff values, how to display it. And in the suggested design in the left hand side, once you click on that, you can see we have not assigned section set to our model. For example, that's why it is giving me the members as M1, M2, M3, M4. As you can see, once you have assigned the section set, for example, for 50 numbers of my column, you have assigned the section set as column, then it will just generate the column here as a section set, and it will help in optimize the design. Otherwise, it will be a long list. Otherwise, it won't create a problem, but this is the workflow I've prefer mostly. So you can see all of my members, and the current shape has been listed here. And in the right, and in the next tab, you can see the RISA provided the suggested shape options and the controlling criteria of its mostly the strengths. And once you click on performing all the like the suggested design option that the RISA has provided, it will help me in my optimizations. So I will just click with resolve with the suggested shape as mentioned. We'll set our section sets and we'll resolve that and check how my members are passing or not. We'll fix this issue. Now in the left hand side, you can see, you can generate your sections sets values from the left hand side Explorer. In the Data Explorer tab, there in the third option, you can see the section set. Once you click on that, you can now group your sections like this section set. For example, I will just name it for the beams, columns, and the braces and the girders that have present in my model. So for bracing, it is already my section set is there. So I will just create a section set for all of my column. Now I will select all of my column and first I will just create a section set and then we'll assign it within the model. For all of my column, I will assign the section set. So once you click on any of the column, you are going to get the shape. For example, right now you are seeing the W4x13 shape. I know that this is not going to perform because W4x13 it's too less for this column and you are not able to bolt it properly. So, but I will just use this and we'll use the reset suggested design feature just to optimize it. You can just select it here. You can just select the AISC database and search it by the number as well. So W4x13, I've just used it. I have assigned each other type to the column. And design list is something that RISA during the suggested design optimization, it will follow this design list, like whatever it's in the design list. For example, our column is W4x13. So whatever the section sets are available for that white flange, it will suggest the shape from that sections particularly. So the design list is important to assign. Similarly, for the columns and the beams, once you click on that W10x26, once you click on any of the beam in the left hand side in the properties, you will display the shape size. So I've just given it a name and assign the type as the beam. And again, it's a white flange. And for my girder, I can select any of the girders and just display it. So 14x34. We've created the section set, then we'll assign it in the model as well. We'll select particular columns and particular beams by using the select by property options. And we're going to select our beams columns members. So as a member types, which we have defined, so it will be selected as a column. And once you click on override previous selections, it will just select my column. So right now you can see on the screen, like my columns have been selected and denoted by the blue symbol. And now we are going to give the section set that we have created. So in the sections shape database, we'll just select the section set instead of the shape database. And the section set has been assigned to the column. So all of my columns has been assigned as a section set. And in the left hand, like in the top here, you can see my columns, in the section set, you can see my columns has been assigned under the section set. Now we'll assign the section set to the beam and the girder as well, and it will display it here. Select by property, again, the same method, like we'll select the beam here and we'll select it. And once we click on override previous selections, because my column is being selected, but I don't want my column to select here. So I will just use the override previous selections. And it will select only of my beams. Now again in the section state, we can just assign it as the beam. Now you can see simultaneously the section set for the beam has already been created. So we'll set it for the girder as well. So we might need some tricks to select our girders. So what I will do is I will just use the elevation view and will select whole of my beams member here. Then I will select just use the line tool to select my beam members, and then I will just invert it to select my girder. So there are different ways to assign. Just I'm just showing it a way how you can use the invert selection tool as well. So it's a line tool. Once you click on any of the line tool, it will select that particular line. And for all of my beams, I'm just use this line feature. Now you can see all of my beams has been selected, but not the girder. So what I will use is the invert selection features. Then it will select my girder instead of the beam. So this is some you might be using that features as well, but this is basically the procedure I must follow. Right now, the section set for my brace, column, beams, and the girder has already been assigned, as you can displayed, as it has already been displayed on the screen as well. So it is here is something called the design list. We'll also set up our design list. And in the design list, once you go on the advanced tab at the top, you will see the options of the redesign list, right? And then you have the options of your database, for example, the AISC database. Once you click on your design list that we have provided in our section set for the white flange, you will get to see all of our sections here. But I am just copying my white flange sections so that I can assign for the assigns my sections. For example, if I want to customize it that my W4 sections is not going to perform well, so that I can just exclude it, so that I'm just creating a copy. Right now, I just want to exclude that from W4 to W6. I don't want to include because I know these are two um, these are not going to perform well, so that I can just select this like from the database from W4 to W6, and I can just remove that. So the design list is something that you can create just to optimize your design. And similarly for the beam, we can just create a copy. Similarly for the column, we can just create a copy and select the white flange. And even for that, I may remove some of the members here. I can just select it and just use the remove. Then after that, we'll assign the design as rules, because we have already created section set and design list. And then what we'll do is create a design rule for of our sections. This is typically for we'll create a design rule for our girders, beams, and the columns. The first tab is for the deflections. You if you want to use the 100, like I have used it as the 1 so that my maximum bending and the shear sex is 100%. If you want to get it more conservative, you can just bring it down to 0.9 or something. Right now I can see for example, what I meant to say here in the design uh, like the design rule is for the girder, for example, I have given a minimum depth of 13 here. For example, in the AISC manual, you might see for the W14, its depth is sometimes 13.9, not the 14. So if I write the minimum depth of 13 here, it will not, like if I write the minimum depth of 14, it will not consider their 13.9 depth, even if the W14. So that is something we need to define here. So that's why I've written here as a 13, for example. Basically, it means the minimum depth should be this much. So I'm assigning such rule here. This is for the deflections for our 3 load case that we have generated at the first. First 3 is for the deflections. So right now you can see the design list. Now we will change it because for the column we have created one design list for which is in the name of white flange under this column. We have created a copy file that so that we can be able to get it here. White flange column you can see. Similarly for the beam we can use the design list for white flange beam. Similarly for the girder we can use the white flange beam options that we have created. Design rule that we have selected for my girder, for example, I have created that minimum depth should be W13. So I can use accordingly the design rule that I have been set. Once I've carried all this, I can just run my reactions and like I can just run my load combination and can check the design later. So I'm just running the bash plus envelope reactions. And you are able to see the unity check right now. Again, my members has been failed because we have not optimized our design. We have just created the section set and assign its values only. Once the analysis and the design is complete, the result tab at the bottom is active. Right now, you can see the difference here. For example, earlier we are able to see in the members, we are able to see the member 1, M2, M3, for example. Right now, you are only see the members with the section sets. Instead of that long list, you are just getting to see only the 4 section sets and under which we have assigned our members. So RISA current shape I am using is visible, and the RISA suggested me some of the shapes here that, sorry. Sorry, yeah, we are in here. So this has given me some suggested shape as well. So we'll run with the resolve with the suggested shape options. So right now we are able to see that all of my members, other members must be passed instead of the brace. Again, because in the multiple iterations, you can solve this. For example, if you don't want to use this suggested shape and instead want to use the other shape, you can just set it from the design rule as well. If you don't want to use the angle section instead of the T sections, for example, if you want to use, you can just change it to the design list, then it will help in the like, for example, like here type in for the braces design list, if you select it as a WT section, then it will give the shapes as per the T section instead of the angle sections. Now the suggested shape is W16 into 3. Right now you can see all of my members have mostly been passed, but this bracing has been showing some issues. So since we, let me check if we run this iteration, then it will solve it or not. So after designing these sections in the multiple iterations using the RISA suggested design feature, now it seems all of my members has been passed right now. Even you can display which of the shapes you are using just from this member icon at the top. You will have all the information related to that particular member, the section size, the materials, section shapes informations displayed in different colors. If you want to see the code seg value, you can just display it from the member icons. And since even if you want to generate the report and want to screenshot this display and want to include it in the report, you can just use this camera icon at the top. It will just capture your image, and later you can just use it in your report as well. And once you click on the snapshot, it will save in your particular folder. And in the top, you can see the options of the print report, and you can just have the options what to include and what not to include in your report. For example, I have included all mostly all the project information here. And if you click on this zoom icon, you will see all the details regarding the name and the date of the report creation. So, and later you can just save it as a print. So you will have all the options for which of your result combination you want to include it in the report. So the detailed report can then be printed. So this is basically the workflow. Like you have assigned the section set and assigned the design list and the design rules, and have used the program suggested feature to optimize the design. So basically, this is the steps which we mostly followed for the still design in the RISA 3D. So I would also like to highlight one of the case study in the RISA 3D that is carried out in the RISA 3D. It's on the mobile stack reclaimer in port of Lake Ohio. So basically, you can see the structural system consists of the steel framing and the steel plate. So it's a long span steel truss and frame, designed to support the reclaiming equipment and the dynamic material handling operations. So, and due to its cantilever length, significant cantilever length, and the continuous operational moments, like it is subjected to different loading conditions like the gravity, wind, or the equipment loading, and the dynamic effect also. So, RISA 3D was used to model and analyze this complete system and all the member forces, deflections, and stability under all the critical load combinations. And it allows to evaluate the multiple operations and the transport scenarios, for example, and optimize the member size using the RISA features and ensure that it complies with the design code. And it also maintain like the RISA Tekla link has also been used here to support the coordination between the analysis and the detailing, so that it improves the design accuracy and reducing the rework during the fabrication and the erections. So we also have detailed case studies on the RISA website, which include several real world examples like the one I have shown. And you get to know like how engineering companies use the software for different kind of the project. So this is not just limited to the buildings, so you can find multiple case study for different types of this structure. So you will also have the flexibility of the modeling regarding the case study, the connection to the Revit, and how they are integration with the other tools. So you can check it out at the risa.com/case studies. You will get all the information regarding the case studies. So moving on, you will see the customer portal. You can access it at risa.com. So it's a platform where you can manage your software license and download all the updates, and it provides links to the tutorials, documentations. And regarding the license type, like we mentioned, it's a cloud-based annual subscription license. And in the right-hand side, you can see the snap of my Risa portal. And in the overview here, like you will see all the RISA product displayed, like whatever the product I'm using. And in the drop down, you have the options through this portal. Admin have the options to add or remove the multiple users under the single license. So you can access all these portals through the portal.risa.com. So we'll display some poll questions here, and then after we can take a few of the questions.
So thank you, Katie, for that very insightful session. Yes, everyone. So please feel free to share your results in the poll, please. And as mentioned earlier, we have a Q&A chat box on top of your Teams application that's open. So if anybody has any questions, any queries you want us to answer here, please feel free to drop your questions. Good number of responses. Yes, thank you everyone for the responses. I just wanted to ask if you have any questions, please drop your questions in Q&A chat box. In the meantime, as you might know that we tried to connect with you yesterday and drop the form for you to ask questions that you wanted to be answered in the session. So in the meantime, while you ask the questions, I do have some questions from our clients, Kirti. So first one is, how do RISA 3D handles design of reinforced concrete shear walls?
So yeah, in RISA 3D, like you can design the shear walls, like the reinforced concrete walls. You can basically model as the wall panels and designed using the built-in design rules. Like you can define the basic inputs like the material, the thickness, and the reinforcement. And RISA 3D checks the wall for the axial force, bending, and the shear. So for the specific, like the special seismic wall, concrete seismic wall, so RISA 3D calculates the shear force amplification factors as required by the ACI 318, and then it used to determine the seismic shear defined, like the demand. So, like basically, it performs the detailed check on the wall piers or the coupling beams and the reinforcement based on the limits as per the ACI provisions, and will you will get to see the pass-fail results and the reinforcement requirement as well in the wall design spreadsheet once you perform the design. And yeah, also regarding the boundary zone, is boundary enforcement, is also addressed according to the code sec, and you can generate all the detailed report like the shear details and the pier or even the wall report. So it's a good topic actually. So we can have a dedicated webinar for this in our upcoming series as well. But yes, you can perform it in the research theory.
Sure, Kirti. Thank you for the answer. We have some other questions as well that was asked by our attendees. Second question was how to provide releases for stream members in DISA 3.
How to provide, you mean releases, right?
Yeah, how to provide releases for stream members.
Oh yeah, so in research theory, like still member release, like you can assign and end releases to control, like which end force or moments are transferred at each end of your members. Like you can make it fully fixed, pinned, or the fully pinned, like the torsion you can release, or the custom release, like the axial shear torsion of the bending moment, like. Basically, you can click on any of your members, like I show on the in my video, and under the general property tab in the RISA workspace, you will have the option to assign releases as I and J releases at the start and end of the members. So yeah, you can definitely assign this. Definitely assign the releases by this way.
There was something about open with steel beams as well. Anything that you can, the question was not really clearly asked, but something about open web steel beams. Uh,
Um, Open. So, like as far as I understand, the thing you mentioned, like the open web still being, is basically I think a member where the web is replaced by an open truss-like configurations, which is basically made of top and the bottom code, maybe connected by the diagonal or the vertical uh, web members. And I think it's commonly used in industrial buildings or the warehouse and the long span structure. So if you're particularly this query is if you can model it in the RISA or not, maybe based on my current understanding, I will just explore it later. But RISA 3D does not have a open dedicated like the open web beam object, but these members maybe I think can be modeled by defining the code and the web member as individual steel members with appropriate of the end releases that this system behave like a truss, and these are really can capture the overall load path, the member force, and the deflections. So I think research theory is mainly here used here to understand the global structure behavior, while uh, its detailed joist or the connection and design is typically handled using the manufacturer guidelines or the separate design tool. So I think I might not have answered it properly, but if anyone of the participant, if you have any of the comments here, you can just write it in the comment box, and we can just reach out. We can just reach out to you through email as well regarding these questions. Like if anyone has additional experience or insight in this particular topic, you can just feel free to share them in the like the chat box. It would be
sure,
great to learn from your practical experience as well.
sure, Vicky. Thanks a lot for that. So we still have no questions from the attendees. I'll just ask you one last question. So how does RISA 3D handle unbraced length and effective length factor calculations for steel members?
So yeah, these are 3D. Definitely, you can define the on this length that I have shown in like I quickly show you like how you where you can define the on this length. Like basically, these are 3D use the on this length, to represent the your actual distance between the lateral restraint. You can, for a member, like you can define this length based on the real brace or the framing point. Like if no value is entered, like the software assume that uh, entire physical member uh, the full member length is assumed as unbraced by default. Like these values are basically used in the buckling and the torsional buckling check. So yeah, when you click on any of the member, you will see the design parameters tab at the left hand side, and you can define the unbraced length as like I mentioned the LB, LComp, and the effective length factor as a K. Basically, the LB and the LComp represent the unbraced length for the like the flexural column type buckling and the lateral torsional beam type buckling. And I think regarding the effective length factor, yeah, I mentioned this can be entered manually or can be calculated automatically for both of your member axis.
Okay. Thank you, Kirti. So, yeah, let's move on. I'll take over. So, if any of you want to explore RISA 3D yourself, we encourage you to try the free 10-day trial. It includes all the features and full support will be provided from Acero. You can directly download it from risa.com, or you can just simply write to us or call us. You can write to us at solutions@acero.in, and we'll help you get started with the software. Here are some of the RISA's current customers. So RISA is trusted by engineering firms worldwide, from consultants to industrial design houses and infrastructure specialists. Its adaptation continues to grow in India, because of its speed, accuracy, and ease of transition from other platforms, similar platforms. Here is some of our clients, what they say, how they review the software. So, first of all, they praise the balance between power and simplicity of the software, making it robust enough to handle complete complex structures and design workflows without being too complex. Right. Second, it's the exceptional customer support that we have provided over the last few years, which many engineers consider best in class. And thirdly, lastly, about the software, the transparency of output, as you have seen in today's webinar as well, uh, and the additional information that RISA provides, it saves time and helps avoid rework. So coming to support and learning at Acero and RISA, support is a priority to us. So you will get dedicated channels via phone, email, and online help. The license will be a cloud-based annual subscription, so it will provide complete flexible licensing. It will not be limited to a single machine, right? And about the learning resources, so as you see, we have been doing webinars for a long time now. We also provide, you can also find online courses. RISA provides tutorials, manuals, and knowledge bases for the complete software learning. So you can explore all of these at the RISA Learning Center, which you can visit by training.risa.com. You can also get certified and stay updated through there. Right. Before we wrap up, just a quick look at what is coming up next from our side. So our next session will be on Bluebeam. It's a powerful productivity and collaboration tool that helps team review markup and work efficiently in PDF drawings. It's coming up in 19th February, so we hope to see you there as well. We have another webinar for Adapt Builder, which is a specialized solution for widely used for concrete design workflows. So yeah, we hope to see you there as well. And here how you can contact us. So you can note down our mobile number and our email IDs. Our office is situated in Noida, Sector 57. Uh, you're more than welcome to please visit us if you are nearby. Please subscribe to our LinkedIn and YouTube. So we do a lot of content consistently, and we try to help you get the most out of your solutions. Lastly, on behalf of Acero Consulting Engineers, I want to thank you all for joining us today. If you like a demo session, custom quotation for any of our offerings, especially for RISA, Bluebeam, please you can write to us or call us. And if you want to discuss our software's integration with your current workflows, please reach out to me directly. Right. Please fill the feedback forms that we have provided you through the chat box. I'll also be sharing that once again. Through the chat box, it helps us it enables us to share the participation certificate to you all and also customize the next upcoming webinar to your requirement. Right. So thank you once again. Thank you, Katie. It was a very informative webinar. Thank you all, and see you in the next webinar. Thank you.
Yeah, thank you everyone. And if you have any of the questions, you can just send it to us and we will reply over the email as well. Thank you everyone. Bye.
Thank you. Bye.